Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share our video and subscribe if you have not subscribed before. Just press on your subscribe button. We have over 240 videos on our platform. It means you can come here and learn any topic of your choice. Topics of mathematics, physics. I'll be talking about mathematics, physics, chemistry. Any topic you have, just come and learn. And any topic you are expecting to be there and is not there yet, you are free to drop comment below. It will surely be responded to. Or you reach us with this line. You can call us with this line. With this line, you can call us. You can WhatsApp us, and also Telegram is allowed. Telegram is allowed. That is okay. In this video, I'll be walking you through this part of physics, which is called. I'll be walking you through which is called energy stored in a capacitor. Energy stored in a capacitor. But before I start this, I have to show one or two questions on both parallel and series circuits. You know, when you have a question, it contains parallel and also contains series. For instance, I have something like this. 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 I have something like this, and also I have another one comes like this, another one comes like this, and that comes like this. Okay, now I have this problem here now, which okay, I have this as 100 mF. I have 60 mF, and I have 40 mF, and I have 24 volts. Now, 24 volts. Let me quickly calculate the current in the circuit combined parallel. Now I want to calculate the current in the circuit. Once I have this problem, I have solution of this one. The first thing I will do, if I like, this is a series. With this is a series, this is the parallel. Now, I will first calculate the combined. Let me now combine the parallel together. Combine parallel capacitant. Capacitant. Now, once I combine it, which it will be equals to 40 plus 60. Don't forget the milled farad, which I'll be having 100, which I have 100 milled farad. Now, since I have it this way, now I will now make use of my, and this would now be in terms of series. Now, with this will be in terms of series. Now, and I've told you the series in form of this. Why total series? Total combined, okay. Total combined or combined capacitor or capacitant. Total combined capacitor, which is going to be C equals to, I've told you earlier, 1 is times 100 divided by 100 plus 100, which it will be equals to 10,000 divided by 200. which this will cancel this, which is going to be 50. Now it means combined capacitor is going to be 50 millifarad. That is all about that. Now from here, now I cannot continue by having from capacitance equals to all over what? Volts, which I've told you earlier. It means my quantity will be equals to, now, which I've told you, it means once I have it this way, I cannot continue by having, what can I do now? It means I'll be having my, this equals to 50 multiplied by 10 raised to power 6 minus this, which I've told you I'm converting this mil to normal farad multiplied by 24. Now this one is the capacitance, while this one is the what? Is the volts, which I will solve by having whatever I have, which it will be equals, it will be equals to 1.2 multiplied by 10 raised to power minus 3 10 raised to power minus 3. Okay, now if I want to calculate the current, my current, which is my current, we always use current as I, which equals to all divided by 10, taking, which I'll be having, whatever I have, it will be equals to, what is my quantity, is multiplied by 10 raised to minus 3 divided by 2. Now time is not given. Since time is not given, I don't need to stress myself. I'm just trying to explain what we have done so far. Just a recap of our previous video. Before you watch this video, make sure you watch we have 5 videos before now on the electric field, which is electrostatics, which is, you need to watch them. Now what I have on this video is on I'm want to work on the energy stored in capacitor. Energy stored in capacitor. Please, by the end of this video, you understand it. Let me quickly start from what is energy stored in capacitor. What do you understand? What can I say about it? It means energy stored in a capacitor. In a capacitor. Is equivalent to the work done in changing, or in charging the capacitor energy stored in capacitor. It means we're talking about what? My work done equals to 1 all over 2 of this. 1 all over 2 of this. Now, since I have that, it means I will be having my quantity, which also can be equals to CV squared, which can also be equals to CV squared, which can also be equals to 1 all over 2 Q squared divided by C. We have mentioned all this in our previous video. Now, any of these equation can be used depending on the terms given. Now, okay, for instance, let me quickly explain 1 or 2 questions with this. Let's quickly go to 1 or 2 questions and let me generate 1 or 2 examples. Now, if I have this question, calculate the energy stored in a 220 mF capacitance or capacitor if the potential difference, this is potential difference between the plants is 40 volts. Now, solution to this problem. I have this problem and I want to solve it. Now, what I need to do is that the first thing I will notice is my capacitance, which is my C, will be equals to 20 mF, which also is equals to 20 multiplied by 10 raised to power minus 6 farad. Now, mH to farad, that is not a problem. Now, what I need to do is potential difference, and I told you that the same thing as what? Volts, which is 40 volts. Now, I can also that my work done, my energy, which is my energy, I use my energy, which is W, equals to 1 all over 2 CV squared, which also can be equal to 1 all over 2. What is my C? 220 multiplied by 10 raised to power minus 6 multiplied by, multiplied by 40, which year 1, year 20. Now, I can now continue by having, now, I'll be having, 40 squared, 40 squared, it's 40 squared because we're going to have V squared. This is going to be V squared, yes. Now, which is 40 squared, it means I'll be having, by pressing my calculator, 1.6 multiplied by 10 raised to power minus 2. 1.6 multiplied by 10 raised to power minus 2 by use of calculator. Now, I think it's getting better. I have this question. The energy stored in a capacitance or capacitor of capacitance 5 mF is 40 joule. 40 joule. What is the voltage applied across its terminal? Now, solution to this problem. I have this problem and I want to solve it. What I need to do is that I have my capacitor, which is, capacitance, which is going to be C equals to 5 mF, which is 5 multiplied by 10 raised to power minus 6 farad. Now, I just convert to farad anyway. Now, it means I'll be having my energy, which is going to be W equals to 40 joule. 40 joule. Now, and I know that my energy equals to 1 over 2 capacitance volts squared. Capacitance volts squared. Now, which I can now put in them in place, which I'll be having 40 equals to 1 over 2 multiplied by 5 multiplied by 10 raised to power minus 6 and multiplied by V squared. Now, which everything can be moved to the other side. We all know what mathematics is saying here. V squared equals to, I have 40 multiplied by 2 divided by 5 multiplied by 10 raised to the power minus 6. Here 1, here I will be having 8. I'll be having 8. Now, this squared equals to 1.6 10 raised to the power 10 raised to the power 7, because that minus will come up and we have nothing to do about it. Now, since I have it this way, which is going to be 16, yes. Now, since I have it this way, and I cannot spread the both sides squared, both side, which I will be having v equals to root of 1.6 multiplied by 10 raised to the power minus 7. And by so doing that, I'll be having which is going to be 4 root of 4 multiplied by 10 raised to the power 3 volts. That is my answer. That is my answer. Now, okay. Let me move to the next question, which to really help. I have this connection, which is going to be a series. Now, this is 6 milled farad, 6 milled farad. Now, everything is the same. Means farad. Okay, let me make it so the same anyway. Now, I have my one, two, three, 4, 5, 6, 7, 8, 9. Now, let me call this 100 volts. Now, I have this problem. Now ask me, 1, what is the effective capacitance? What is the effective capacitance in the circuit? 2, what is the total energy stored by the capacitor. Solution to this problem. Now, I have this problem. The first thing I want you to know is that the connection is in series. This is a series connection. Now, it means effective capacitance will be equals to 1 over C. 1 over C equals to 1 over C1 plus 1 over C2 plus 1 over C3, which we have 1, 2, 3, which 1 over C equals to 1 over 6 plus 1 over 6 plus 1 over 6, which I have 1 over 6 equals to, I have 3 over 6, which I have 3 over 6, which 3 over 6, which is written as what? My C, 1 here, 1, 2, which is going to be, my C will be 2. It means my capacitance is going to be 2 milled farad. This is very important. We are moving on milled. If you want to convert to farad only, just to be implied 2 multiplied by 10 raised to the power minus 6 farad. This anyhow you want to do it. Now, since I have it this way, that is the first question. The second question is, what is the total energy stored by the capacitor? Now, I've told you earlier, now we have our potential difference, which is by potential difference, which is known as volts, as 100 volt, and I have my capacitance of this, which is my capacitor. And I've told you that my total energy stored, which is going to be W, equals to half CV squared. Half the CV squared. Now, since I have it this way, I cannot continue by having my total energy stored, which is going to be 1/2 multiplied by what is my C. I have it as 2. It's good to use it as 2 multiplied by 10 raised to the power minus 6 multiplied by what is my V. My V is known as 100, which is I have 100 squared. Now, by so doing this, I know that this will cancel this. Now, which I'll be having 10 raised to the power minus 6 multiplied by 10 raised to the power 2 multiplied by 2, which I have 10 raised to the power 6 multiplied by 10 raised to the power 4. Yes. Yes, 10 raised to the power 3 power 4, which I have my what equals to 10 raised to the power minus 6 plus 4, which is 10 raised to the power minus 2. 10 raised to the power minus 2. Now, since I have as 10 raised to the power minus 2, I can now write it as well as equals to 0.01 joule. That is what we're talking about. Yes, joule. Or you put it like this, joule. Anyhow, you can also put it 1 multiplied by 10 raised to the power minus 2 joule. Anyhow you want to do it. You are free. That is all about that. Now, okay, let me give a last question on this last question under this, which it will really be very comprehensive and well defined. Okay. Now, I have this question with me here. Now, I have this question. The plant of a parallel plant capacitor are 5 millimeter apart and 2 meters squared in area. The plants are in a potential difference of 1000 volts is applied across the capacitor. Calculate the 1 capacitance, 2 charge on each plant, 3 electric intensity in the space between them. 4 energy stored in the capacitance or in the capacitor. Now, permittivity or free space is equals to 8.85 multiplied by 10 raised to the power minus 8. This is why n. Now, let's see this question because it's very comprehensive, and this class will end there. Now, solution to this problem. The first thing you are asked to find, let's quickly write out what is given to us. The first thing I have is distance, which is my distance is apart, which is going to be d. It will be equals to, we have 5 nm, which I will try to relate it to what? To meter. Now it will be 0.005 meter. Yes, millimeter. Yes, yes, yes. Now my area, which is my A, it will be equals to 20 meter, which is very potential difference, which is voltage, it will be 1000 volt. Now, and my base is equals to 8.85, which is going to be E naught. I've explained it earlier. Power 12. No, power 12. And C. Now, I cannot continue by having my capacitance. That is number 1, which is known as my capacitance, which is, I call it C. It will be equals to E naught A divided by distance. E naught A divided by distance. My E naught is given and my A is my area. Distance is D, which I will be having. My capacitance will be equals to 8 multiplied by 8.85 multiplied by 10 raised to the power minus 12 multiplied by what is my A. My A is known as area, which is 2 divided by my distance is known as 0.005. Now, which I will have my capacitance will be now be equals to 1.77 multiplied by 10 raised to the power 11 divided by 0.05, which also implies now it will be 3.54 multiplied by 10 raised to the power minus 9 farad. Minus 9 farad. That is my capacitance. Now, the next one, I'm asked to find the charge on each plant. Now, if I'm to find a charge, which I'll be having my charge, number 2, my charge, which is, I call it Q, it will be equals to CV. Now, we all know what my C, which will be 3.5 multiplied by 10 raised to the power minus 9. What is my V? My V is known as 1000, which I will have it, my charge, it will be equal to 3.56. Now, this is 3 and multiplied by 10 raised to the power minus 6. It's a matter of indices. I'm just using indices at this point. Charge is always on. Okay, now that is my charge. Coulomb. Now the next 3, which is number 3, to find this is going to be electric intensity. It will be equals to electric intensity. It will be equals to, which I normally denote it by E. For my past video, which I noted by E, it will be equals to V all over distance, voltage all over distance, which we all know what my voltage is. What is my voltage? I have 1000 divided by my distance, which is going to be my distance is going to be 0.005, which I have it as it will be increased, which it will be equals to 2 multiplied by 10 raised to power 5. Power 5, we have Vm per meter squared, voltage per meter squared. The last one, which is the energy stored in the capacitor, which is number 4. The energy stored, I've told you that energy stored, which is always denoted by what? By W, it will be equals to, let me put stored, it will be equals to 1/2 CV squared, which I've explained earlier, which I'll be having equals to 1, what is my capacitance? 3.54 10 raised to power minus 9 multiplied by, what is my volt? 1000 squared. 1000 squared, which I'll be having, okay, I have multiplied by 1/2 because of this 1/2, which by my calculator, it will give me 1.77 multiplied by 10 raised to power minus 3. That is all. That is all. That is all I have for you. That is all I have for you. Don't forget that you are on with Further Solutions Academy. Further Solutions Academy. Encourage us all to share, and if you have not subscribed, please so make sure you subscribe. If you are enjoying our video, just subscribe to it. We have videos for you, a lot of videos for you. And to reach us, you can drop a comment below. Drop a message below, or you call us with this number. With this number, you can call us, you can WhatsApp us, and Telegram is allowed. Thanks for watching.